start things off. Your work basically aimed to look at post-war buildings. You did provide some kind of idea on why you chose to do them, but would you be able to give us more kind of reasons why you particularly looked at post-war buildings here in the UK?
It is mainly because they have really high energy consumption level. After 80s, there are some regulations that not very good level, but to an acceptable level to convert buildings. So between 45 to 80s, there is really nothing that considers any energy consumption or thermal improvement. So that these buildings are very high consumers. The first thing was this. Also, they are more. How can I say it? They have had potential to have a retrofit because of the level of they are not like skyscraper, for example, or very high-rise buildings, or they are not. They don't necessarily need mechanical ventilation as open office buildings that also has high energy consumption. They are more likely to be able to provide it comfort by using passive cooling methods. This sort of they require retrofit for sure, like other buildings, but they also have potential to be retrofitted in a passive way. I think that's what the main two things.
Okay, thank you for that. Hannah?
I guess it'd be quite interesting to understand, almost from the three presenters, so the different ways that you're looking at uncertainties in your work. And obviously the two using energy costs and like some similarities, and whether there's any, how that compares with what you're doing, Jonathan.
Well, I mean, uncertainty in the kind of work that I'm doing is a little bit tricky, because it's inherently all statistical models, and a lot of it is basically various forms of regression, and inside those you can always say, okay, well, we have some kind of R-squared value or something which gives you an idea of the fit. But then the real uncertainty is not necessarily the same as a statistical uncertainty. So you use a statistical tool which will give you some value, but that doesn't automatically correspond to the difference between your model and the real world. Then on the other hand, the model is known to be an approximation. So there's a lot of different aspects to it. So for instance, I can try and estimate uncertainty by finding some measured data and seeing how my values correspond to measured data. And that's really the sort of best case scenario, but there's not very much of that. So to some extent, uncertainty also becomes a question of, can the values I produce give you a good enough result for a specific purpose? So for instance, can I estimate a heat loss coefficient that can, at the very least, distinguish between a well-insulated house and a not well-insulated house to give some kind of index? And that's the sort of, I suppose you have three types of uncertainty. You have the uncertainty which is, do my results allow me to distinguish between sort of important properties for a specific purpose? Then there's the uncertainty, how well do the results match with some form of measured data? And then you have the most broad, which is, what's the sort of statistical uncertainty as a result of the model? So yeah, I think that's the answer. You can't really boil it down any more than that. It's, yeah.
I think for me the most important tool is sensitivity analysis. You can't really get rid of uncertainty in modeling at all. Like, there is no model that have no uncertainty in it. It's not possible. So sensitivity analysis itself helps you to determine focus on which inputs, which is quite important, I think. I think it's always about defining the range, like the range of input itself, the range of the output also, and comparing them with the anything existing, works or statistics or that sort of stuff, and then finding where you are in that range. If you are in a proper limit, I think then it's fine, because it's really not possible to get rid of uncertainty.
Yeah, and for me, I think I'll include the occupancy regimes, which is like different family compositions in the buildings, and also different types of flats. So there will be quite a lot of sensitivity study to see maybe a flat located, old flat, and also two people living in a flat may have one sensitivity which is the highest. Maybe the newer building with 4 people in the flat may have other parameters which is more sensitive. And I think this kind of method can ensure a more accuracy of the model than just using one building and do a sensitivity study and see what kind of parameters will be more sensitive and then do the optimization.
Yes, there's a question at the back.
Yeah, I've got, it's a sort of a follow-on question, really. It was really good to hear that you were all thinking about how realistic the results of the models might be. And a lot of people use the word validation. So I wondered to all 3 speakers, if I gave you all the money that you needed, how would you validate your models? What would that take? Is validation the right word to use? Thoughts?
In my case, as I'm trying to deal with the building stock, then you should have a lot of money, really.
As much as you want.
It should be done measuring all those buildings that are that I could represent with the model, I guess, and then looking at the averages out of it. So yeah, I'm also questioning if validation is the right word to use.
I mean, I've been told not to use validation as a word by my supervisors. It may have slipped because it's otherwise you end up sort of with some horrible phrase. It's more about comparing the results from different methods. So in a sense, the method I use is tautologically correct in that the results that the method provides are the results you get from that method. And there are other methods which will measure something which will hopefully be related to the values that I have measured through my method. Now there is another method called coheating, which is probably the closest, which involves taking a building, throwing everybody out of it, doing highly controlled tests of energy losses. Because that's quite work intensive and intrusive, there's very, very few buildings that's actually been done on. Maybe that would be, the ideal would be to have a range of different building types which have had this performed. The next best, which thankfully for me actually has been done, is to just build a bunch of buildings of slightly different varieties and do measurements on those. And that was actually done by Bob Lowe in the 80s. And I have that data set, which hopefully that's going to be part of my verification. But of course then you have the data is maybe quite old, it's not going to have the same sort of resolution. Getting things like weather data for that period is going to be not as nice as having it for the last 2 years and so on. So yeah, that would also be quite good. And then maybe the third and maybe most scalable thing would be to have at least internal temperatures for a lot of buildings, because that is a very important data point. And since people are starting to get things like smart thermostats, that might actually become a viable data stream that's going to come along with energy data. And similarly, an interesting development is people also starting to have smart boilers, which report a lot of their internal, what's going on, like the power they're using, they're on and off. And that can also be an important potential data source for improving results.
I like the verification word. I think that's very appropriate in that context.
Yeah, and for me, I think to put meters to measure the energy of the buildings itself, and because initially we used some codes and regulations or assumptions in the model, which is the base case model, but to perform modeling, the base case model is actually really important as the accuracy. So by measuring the actual energy consumption and compare with the base case model, we can change kind of the inaccuracy of the input parameters, which will lead to a more accurate result. And for how to do the modeling, monitoring and stuff, because it's quite early of my research, so I don't really have a formulate idea of it, but it might be done in the future work of how to measure the energy in the buildings.
I think we have time for one more question. Okay, we've got two. Okay.
I've got a very specific and quick question for Jonathan, which is, yeah, you talked a little bit about the poorly behaved buildings within that schema. Do you have any sense of what percentage that constitute?
Right now, I can't say for sure, mostly because I've made some changes to my data loading because I found some problems in some of the input data sets I have. And I haven't yet gotten around to rerunning everything to find out what now works and what doesn't. In terms of just getting a value which is not completely insane, it's something like 80% of buildings will at least provide you a value within a reasonable range. So, you know, you don't have internal temperatures of like -12 or 55 or something. How that translates into more verified ones with like lower errors, I'm not too sure yet. And I suspect there are certain buildings which display certain consumption patterns where you'll just be able to see quite clearly that it's something quite unusual that's going on. And I think that will be actually quite an interesting thing to look at. I don't think I'll get around to it in my PhD, but I hope to sort of leave that as an open question.
One final question.
Just a very quick one. I was wondering what data set you used, the smart meter data.
So I've got a few. The biggest one is called EDRP, the Energy Data Research Project. That's got about 14,000 buildings in. The smallest one is the micro CHP trial data, which has some control groups with regular boilers, which is useful because it has quite a lot of internal monitoring. So, and then in between I have a subset of EDRP which has also more metadata, because you all sort of end up with a trade-off. The bigger data sets tend to have rubbish metadata and the smallest data sets have good metadata. So I'm trying to work with a range of those. Yeah.
And to use the secondary data, especially EDRP, how easy was that to use the?
I mean, EDRP, in terms of the metadata, do you mean?
Yeah.
Yeah, EDRP, they've put quite a lot of effort into making sure it's useless. I don't know why they made so much effort, but really they've sort of stripped out almost anything that would tell you anything useful. So for me, that's more sort of proof of scalability. If I can make it work on the EDRP data, then I know I can make it work on just about anything. Yeah.
I'd like to kind of bring this session to a close. I was delighted to hear the range of sort of applications there was for modelling as a research technique, and also quite happy to learn that ION researchers here are quite aware of the challenges involved. I hope that for the students and researchers who attended this session, a lot of ideas came out of this session in terms of applying it to your own work. I think we have lunch in about 2 minutes, I think. So if we'd like to get a head start and beat everybody to the session, again, I'd like to just thank all of our presenters. Thank you very much.